Worksheet 1221, multiple choice, just a quick one. You should have tried all these problems already. At this point, you should be getting pretty good at this stuff. So if you have tried them and checked your answers and got any wrong, here's an opportunity to figure out how to do them. So I'm going to go through them right now. So the first is the graph of this function has a relative max where. So we want to take the derivative, 6x minus 3x squared, set it equal to 0 undefined. To find critical points, undefined is not going to happen here. Factor a 3x out. You have 2 minus x left over. So x equals 0 and 2. Those are your critical points. We'll do a line check. Put 0 on there, put 2 on there, test a point. X equals 3. It's going to turn out negative, positive, negative. So we are decreasing, increasing, decreasing. This is a relative max. This is a relative min. You wanted the x. It says the graph has a maximum at. So we're looking for the x value. Now they're given all ordered pairs. I mean, based off this, I think we could safely say it's C. But if you wanted to find the y value, y coordinate there, plug it back into the original. And we would get 12 minus 8 is 4. So there you go. That's an x coordinate. That's a y coordinate. Number 2, the maximum. The maximum. That's absolute. It's also the y value. So we're going to try to do EVT. These are your endpoints. Got a closed interval, continuous function. It's eligible for extreme value theorem. Take the derivative. 6x squared minus 18x plus 12 equals 0 undefined. You got to find critical points. You can factor 6 out of everything. You get x squared minus 3x plus 2. This just makes the next factoring step easier. Quadratic trinomial. Minus 1, minus 2, x equals 1, x equals 2. Those are your critical points. We're going to make a little table. Plug these in to the original function. 2x cubed minus 9x squared plus 12x minus 1. Endpoints, negative 1, 1, 2. Critical points on an endpoint, whatever. Plug negative 1 in. We get negative 2. Minus 9 minus 12 minus 1 is negative 11, negative 23, negative 24. Plug positive 1 in, you get 2 minus 9 plus 12 minus 1. Negative 7, 5 is positive 4. Plug 2 in, you get 16 minus 36 plus 24 minus 1. It's going to be, let's see, negative 24 minus 1 is 3. We're looking for the max. This is the max, and we want the max value, the y value. So don't put 1. You got to read the question closely. Number 3, a little fundamental theorem of calculus part 2, FTC part 2. If you take the derivative of an integral, they cancel each other out, and you plug limits in one at a time, but you got to watch out. So you got to do sine. You plug x cubed in minus sine, got to plug x in, but then you got to multiply by the derivative of what you plugged in. 3x squared, just what you plugged in. So the final answer is 3x squared sine of x to the 6th, rules of exponents, minus sine x squared, 3x squared. So that looks like answer C. But you got to remember that, do that extra chain rule step at the end. Number 4, suppose that f is continuous function defined for all real numbers. They give you a value here, another value. It says f equals 0 for one and only one value. They're saying if that's true, then which of the following could be x? So this is an intermediate value theorem. It's got to go from 3 to negative 2, so it's got to hit 0 between negative 5 and negative 1. So somewhere between x equals -5, and x equals -1. So it can't be -7. It can't be 0, 1, or 2. It would have to be -2 as far as those possible values. So that's intermediate value theorem. For what values of x does this have a relative min? So we got to take the derivative. 24 x to the 5th minus 24 x squared equals 0 undefined. Undefined is not going to happen. Factor out the 24x squared to get x cubed minus 1. So x equals 1 and x equals 0 are your critical points. Now you got to watch out. This one is an even repeated root, so the graph actually bounces off there. So it's not going to change sign there. Test a value. X equals 2, positive, negative, negative. So it's decreasing, decreasing, increasing. And so here's your relative min. That's like a plateau. We want to, do we know the x? Values of x. So 1 only. Okay. Number 6, another fundamental theorem of calculus part 2. So derivative does an integral, then you got to plug limit in. So we're going to get 1 over 1 plus 0 squared minus 1 over 1 plus x squared. Then you got to multiply by the derivative of what you plugged in. And we plugged 0 in, plugged an x in. So it's going to be negative 1 over 1 plus x squared. There we go. B. C says the minimum value. So that means absolute, and we're looking for the y value here. So we don't have any endpoints, so we can't do extreme value theorem. We could try and use the table to sort of analyze it, or we could try and do first derivative test. Either way, we still got to find critical points. So derivative this, say equal to 0 undefined. So e to the x equals 2. Take the natural log of both sides. So x equals natural log of 2 is your only critical point. That doesn't, okay. If we did a table, we'll plug it back into the original. Since there are no endpoints, then we kind of have to take the limit as x goes to negative infinity and the limit as x goes to positive infinity, and then try natural log of 2. Now, as you go to negative infinity, you're going to get e to the negative infinity minus 2 times negative infinity. Now, e to the negative infinity, that's 1 over e to the infinity, which goes to 0, but you're still going to positive infinity. If you go in positive infinity, you get e to the infinity minus 2 times infinity, and that's going to, this goes to infinity, this goes to infinity. We're subtracting it, but this is the dominant term, so it's going to go to positive infinity. So here, if you do e the natural log of 2 minus 2 natural log of 2, that's going to be 2 minus 2 natural log of 2. And they said this has to be the absolute min because it goes up forever on both sides. So this is a relative min, but it's also the absolute min, which matches answer D. Now, we could have done first derivative test potentially. So we do a line check with f prime of x, put the only critical point on there. Test a point, x equals, I don't know, natural log of 2, by the way, is definitely positive. So if we tested 0 over here on the left, then that'd be e to the 0, which is 1 minus 0. That'd be, well, we got to test it in f prime. E 0 is 1, minus 2 is negative 1. So this would be negative, positive, decreasing, increasing. So this is a relative min by the first derivative test, but since it's the only relative extrema, it ends up being the absolute min value. Now that's the location of it. They want the min value, which is the y value. So you still got to plug this in. Even if you did this way, you still got to plug this back into f of x to get the actual min value. Okay? Got a few more problems in the back. Some good practice. So, number 8, which of the functions below has an average mean value of 0 on the interval negative a to a, and a has to be positive. So I'm assuming there's only one answer, but we could do this kind of visually. Sine looks like this, right? So if we go from like negative a to a, the average value, f average, equals the integral from negative a to a of f of x dx. And then we divide by the base of the rectangle, which would be 1 over 2a. But it's all about this integral right here. So if you integrate an odd function from negative x to a positive x, it's going to give you 0. So that one's good. Cosine doesn't. Cosine's like this. So if you go from like negative a to a, it's usually going to give you some value. So not that one. I think it's a. Square root of x looks like this. It doesn't even exist at negative a. So that's a problem. Absolute value looks like this. If you go from negative a to a, you're not going to get integral of 0. And I don't know, this one, x squared, I mean, that looks like a quartic, which looks like a parabola, negative a to a. So any even function is probably out. We had an odd function here, which had that property. So, I mean, you can do all the work if you want, but that's a quick way. Number 9, let f be a differentiable function. That means its derivative exists everywhere, which means that the original function is continuous and exists everywhere. It's a smooth graph. Which of the following must be true? If you take the derivative of the integral, you get f of x. With 0 and 3, now you get f of 3 minus f of 0, but then you got to multiply by the derivative of what you plugged in, which means that this actually equals 0, which kind of makes sense. If you integrate something, a definite integral, you're going to get a number, right? And then you're going to take the derivative of the number, it's going to be 0. Here, the integral of f prime gives you fx, but then you still have to do f minus 3. So that one's out. This one, if we take derivative of that, you're going to get f of x times the derivative of what you plugged in minus f of 3 times the derivative of what you plugged in, which is 0. And so then you will get f of x. So that one's right. 3 is the only one that must be true. Number 10, average values. That's mean value theorem. So we know that f average, we integrate the curve and we smooth it out. The smooth out height is the average height, and smooth out area is area of a rectangle now, divided by base of the rectangle. So we just got to figure out what this is. So this is 3x to the 1/2. Now we could do 3x to the 3/2, divide by the new exponent, multiply by its reciprocal, but there's a chain rule thing here where extra 3 is going to pop out, so you need an extra 1/3. One way you could have avoided that is had the square root of 3 and the square root of x split up, which you're allowed to do, and then you could just put a square root of 3 out in front. This is the same thing. So what do we have? We have 2 over 81, 3x to the 3/2, if we do it that way. And then we've got to plug 0 to 9 in. So you plug 9 in, you get 27. So 27, let's see, you get 27 to 3/2 minus 0 to 3/2. So that term drops out now. Square root 27, that would give you 3 square root 3, but then we're going to cube it. So that gives you 2. 3 cubed is 27, but then you have the cube root of 27 over 81. You could reduce that. You can take another square root of 9 out of that. And you have 2 times 3 times square root of 2 over 3. Final answer is 2 square root 2, or 3. That's supposed to be a 3 there. 2 square root 3. Number 11. The slope of the function. So the slope of this, so we're looking for f prime at 0.4. Now this is a graphing calculator problem. So now if we take the derivative of this, in general, so we're looking for that, but f prime of x in general, fundamental theorem of calculus, you're going to get arc sine of x times the derivative of what you plugged in minus arc sine of 0 times the derivative of what you plugged in. So that goes away. So f prime of 0.4 equals inverse sine, which is another way of writing arc sine, which is a little more common for us. And since those answers are all decimals, I guess we'll just plug this in our calculator. Now remember, your calculator gives you principal values. So inverse sine of 0.4 should be giving us a first quadrant answer, 0.411516. Now, let's see. Is there any reason we should not go with the principal value answer? I don't think so. If they give you inverse sine, that usually implies principal value. So, okay, 12, the mass m in grams of the plant T weeks after it begins growing is, so this kind of looks like some kind of growth thing. What is the average rate of change? Average rate of change. So this is the mass. So we're looking for average MT in grams per week during the fifth week. And T is in weeks, so maybe should we do during the fifth week would be between week 4 and week 5. So we do M5 minus M4 over 5 minus 4. And so we could use our calculator to do that. 5 e to the 5th divided by 80 minus 4 e to the 4th divided by 80, and then that's going to be divided by 1, so it looks like it's 6.545914. There we go. Answer D. Number 13, let f be a function whose derivative is, so they're giving you a derivative, and I don't think you're going to be able to integrate that by hand. This is a graphing calculator problem. How many relative maximum points does f of x have? How many relative maxes does it have from 0 to 12? So our best bet, since we have a graphing calculator, because otherwise we set this equals 0 and define, we can do line checks and stuff like that, but that might be a lot of work or just take a long time. So I think we're going to graph this x divided by 15 plus sine of e to the 0.2 x, close, go to window, 0 to 12, and then we could do zoom fit as long as it doesn't backfire on us and give us a huge graph. But we can look at the derivative graph and identify relative maxes and mins. We should be really good at that. So increasing, decreasing, increasing, decreasing. So just to sketch that, not that you would need to on the AP test, but this is what looks like we have from 0 to 12 of f prime of x versus x. So this is positive increasing, negative decreasing, positive increasing, negative decreasing. These are critical points because the derivative is 0. And first derivative test says if you go from increasing, decreasing, you're going up, then you're going down, that's a relative max. You're going down, then you go up, that's the bottom, relative min. Going up and then down, that's relative max. So we have 2 relative max points. Real quick, we don't even have to find what they are. Anyways, I hope that's some good quick review practice for your AP test. You guys should be getting really good at all this stuff.